Three. Hi, we're Jennifer and Marianna. We'll be doing a design exploration video on Team 449's lobster robot. Team 449, also known as the Blair Robot Project, is from Silver Springs, Maryland. They started FRC in 2000, and in 2025, they ranked number 2 in the Chesapeake District, having earned 342 points. This robot was specifically used in 2025 for the Reefscape game. Mariana and I chose this robot because we were intrigued by their elevator, and we watched multiple competition videos where we got to see the lobster robot in action, and we saw how flexible it was on the arena due to their design. The primary design challenge for Reefscape was to create a robot that could reliably score game pieces, known as corals, onto designated scoring areas called the reef, while also being fast, stable, and adaptable during matches. The robot needed to 1. Efficiently collect game pieces from the ground, 2. Control and move those pieces internally without jamming, 3. Place corals at multiple heights on the reef, 4. Remain stable and balanced even when extended, 5. Reposition quickly to respond to changing match conditions. Every design decision they made came back to these goals. Team 449 has a long history of designing competitive robots, and each season focuses on improving specific weaknesses from the previous year. In past seasons, they identified areas where they wanted to improve. They wanted to improve and have a faster and more precise movement, better control of game pieces, increased scoring consistency, improved mechanical reliability, and for Reefscape, their main focus was precision, flexibility, and efficiency, making sure the robot could score from multiple positions and heights while maintaining stability and speed.
So, now talking about the robot itself, we will be talking about the overall robot strategy related to Reefscape. The overall strategy of the robot centers on 1. Rapid repositioning using an advanced drivetrain meant to quickly move around the arena. 2. Reliable ground intake to quickly collect corals for maximum efficiency. 3. Controlled internal indexing to prevent jams and not lose match time. 4. A multi-level elevator to score on all reef heights for better scoring. And 5. A climber to complete endgame objectives, which could earn more points. All of these systems work together to allow the robot to score consistently throughout the match. Now, breaking down the robot into its major subsystems, which is relevant to its overall robot strategy, we have first the drivetrain, second, the ground intake, third, the indexer, fourth, the elevator, and finally, the climber. These are the subsystems we'll be talking about. Each part was designed with both performance and reliability in mind.
So, the first one we'll be talking about will be the drivetrain. This robot uses a swerve drivetrain, which means each wheel can rotate independently. This design allows for the robot to move in any direction without turning, make quick, precise adjustments while lining up shots, and rapidly reposition between scoring locations. The significance of swerve drive is that it gives them a huge competitive advantage. You can approach the reef from optimal angles, dodge defenders, and line up scoring actions more efficiently than traditional drivetrain, while swerve drive is mechanically and programmatically complex. The payoff is speed, agility, and precision, all essential for Reefscape. So, the second subsystem that we will be heading into is the ground intake, which is responsible for collecting corals from the field. The intake pulls corals in through the lower front area of the robot. Once the coral is captured, a system of balls moves it upwards and into the robot. This internal ball path design allows for fast collection, reduced risk of pieces falling out, smooth transition into the indexing system, and because the intake opening is relatively narrow, the programming team should have implemented object detection to ensure the system only runs when a coral is present. This helps prevent jams and unnecessary wear on the motors.
So, once the coral enters the robot through the ground intake, it travels through the indexer, which is the next subsystem we'll talk about. The indexer's job is to control spacing between corals, ensure only one coral is positioned for scoring at a time, and to prevent jams. It needs to prevent jams because that can cost valuable match time. So, in the indexer, by carefully controlling the movement of corals inside the robot, it improves reliability and scoring consistency. This subsystem acts as the bridge between intake and scoring. Next, we'll talk about the elevator. This is probably one of the most important subsystems on this robot. Specifically, this elevator allows the robot to extend upward to place squirrels on the reef to score points. It can also score at 3 different height levels, which maximizes the scoring, and it adjusts quickly depending on match strategy. This elevator has a maximum extension of 18.5 inches, which was carefully chosen to balance reach with stability and not exceed the limit set in the Reefscape game manual. If grip is lost while placing a coral onto the reef, the design of the robot ensures that the coral falls safely onto the robot body rather than off onto the field. So, by having multiple extension levels, the robot can score efficiently at different reef heights without wasting time on unnecessary movement.
So, the last subsystem we'll talk about is the climber. The climber is used during the endgame as a portion for the match. Its purpose is to secure the robot to the climbing structure, earn additional points for the alliance, and complete match objectives consistently. The climber was designed to be simple and reliable, ensuring it works under pressure when matches are often decided by a small margin. So, now we'll be talking about why Team 449 built the robot this way. Every design choice on this robot was intentional. One major feature is the pivot system, which allows the robot to score from both the front and the back. This greatly increases flexibility and reduces the need to turn around during matches. They also focus heavily on maintaining a low center of gravity. Even when the elevator is fully extended, the robot remains stable, reducing the risk of tipping. The elevator design itself also contributes to both scoring versatility and balance, allowing them to reach all scoring levels without sacrificing control. Overall, this robot was built to be fast, stable, precise, and adaptable.
So, in conclusion, to summarize everything we've talked about so far, Team 449's Reefscape Lobster Robot reflects a commitment to smart engineering and strategic design. From the swerve drive that enabled rapid repositioning, to the ground intake and indexer that ensured reliable game piece control, to the elevator and climber that maximized scoring potential, every subsystem worked together to meet the demands of competition.
Mm.